Hello everyone, welcome to Coders Camp. We are at 30th day of June LeetCode challenge, and the problem we are going to cover in this video is lowest common ancestor of a binary tree. So the input given here is a binary tree and two values P and Q, and we have to return the least common ancestor or the lowest common ancestor between the nodes P and Q given. And the definition of lowest common ancestor is if there are two nodes P and Q, as the lowest node in the tree has both P and Q as descendants, and where we allow a node to be descendant of itself. So let's understand this with an example. So here is the given example in the problem statement. So as per the definition of lowest common ancestor, it is said to be P and Q are two nodes, then the lowest common ancestor is something that has both P and Q as its descendants. In other words, they both share a common parent. So here in the first example, P and Q given are 5 and 1. So in this case, we have to find an immediate node or the lowest common node that share both of this P and Q nodes as its descendant. So here if you see 5 and 1 have a immediate common parent as 3, so 3 is going to be the output. So consider P is equal to 5 and Q is equal to 4. So if you see 4 is one of the sub node in under 5. So if you go to 5, they both have the common parent as 3, but as per the definition of LCA, a node can be its own descendant. So in that case, 5 can be its own descendant. So 4 also comes under 5. So both of them share a common parent, or both of them are descendants of 5. So 5 is going to be the output here. If suppose you consider any node that is 0 and 8, then the lowest common ancestor of 0 and 8 is going to be 1. So hope you're getting the overall idea of this problem. So how are we going to approach this?
So let's start by having only two children with one root node. So our root node is 3 and the left child is 5 and the right child is 1. So now we have to search for 5 and 1, as 5 and 1 are our P and Q, and what would be the lowest common ancestor of a binary tree. So 5 is the left child and 1 is the right child. So in that case, there is a partition from the root node 3 towards left and right. So the common ancestor that possibly 5 and 1 could share is its root node. For example, we don't have a 5 at this end, but we have a 5 as a child of 1. So in that case, we would be having both 1 and 5 towards the right side of 3. So 5 and 1, they both share a common ancestor as 1 itself, because as per the definition, a node can be its own descendant. So that 1 would be the result. Same way, if 5 and 6 are P and Q and we have to find the lowest common ancestor, then 5 would be the lowest common ancestor of both 6 and 5. So what we are trying to overall say is we are going to search for the placement of P and Q in our tree. So if P is in a left side and Q is in a right side, or vice versa, that is Q is in left side or P is in right side, so in that case there is a division between P and Q on both the sides of a root node. So there must be a root node that has P on the left side and Q on the right side, or vice versa. So in that case, the root is going to be the lowest common ancestor of these two nodes. So this is our condition 1. If suppose we find P and Q on the same side, either on the right side or the left side, then the P or Q, whichever occurs first, would be the lowest common ancestor. For example, if we are trying to search for the lowest common ancestor of 5 and 4, both 5 and 4 are going to lie towards the left side of the root node. So in that case, 4 is going to have the lowest common ancestor, or ancestor as 2, but 2 is not an ancestor of 5 because 5 lies ahead of 2. And then 2 go back to 5, where 5 is actually our P. So in that case, 5 is going to be the lowest common ancestor for both the nodes 5 and 4. So the overall logic is simple. If we have a partition, or we have a P and Q towards left and right side of a tree, then the root is going to be the lowest common ancestor. If not, if both the nodes are going to be in either of the side, that is either left or right, then in that case, whichever node occurs first is going to be our lowest common ancestor. So hope you're understanding this logic. This is going to work in big O of n time complexity, as we are going to do a basic DFS to find our positioning of P and Q and return the result based on it. So let's get into the code now. So we are going to check if root is not equal to null, then we are going to perform a basic DFS function to find where our P and Q is placed. For that, we are going to have two tree nodes, left and they both gonna call this function recursively to find the placement of P and Q. So tree node left is going to search towards the left side of our tree and the other one is going to search towards the right side. So here we are going to have a base condition that if it found the P and Q in our tree, then it is going to return that node's placement. So if the current node we are searching is either P or Q, then it is going to return that particular node. So once it is returned, our function is calling it recursively and it is going to get the root in left and right. So here if our node is found towards the left side of a tree, then our left node is going to have some root value, or if it is in the right side of the tree, then our right node is going to have some value. If not, it did not find in that direction, then it is going to return null. So here we are going to check if our left is null and right is null, then we have to return null because we did not find our root. Else, if our left is not is equal to null and right is also not is equal to null, then in that case we have found one node in the right and one node in the left. Either it can be P or Q in both the sides, but we have found them in different branches or different subtrees of the root node. So in that case, the possible lowest common ancestor of both the nodes are going to be its root. So we are going to return root as the lowest common ancestor. Else, if either of one is null and the other one has the value, which means if either of one has a value, that is if right is null, then left is not null, which means we found both the nodes in the left direction of the tree. So in that case, left is going to be the possible common ancestor of that particular P and Q. Same way, if our left is not equal to null and right is not null, which means we have found both P and Q towards the right side of our tree, which means our right is going to be the lowest common ancestor. So yes, this is it. Finally, we are going to return root if none of the conditions has been satisfied. So yes, let's run this and try. So yes, let's submit. Yes, the solution is accepted and runs in 4 milliseconds. That is the 100% fastest of all the solutions submitted. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.